All right, hello everybody. This is a tutorial help for question 8.45 on mastering geology. Before we go into it, just so you know, this is a difficulty 5 question. This would never be a type of question I would ask for you to know on any midterm or exam, but it is an extra credit question this week on your mastering geology that I will help guide you through. In addition, I'll extend a little bit of time as well in mastering astronomy so that you can make your way through this assignment. So I'm going to guide you through, and you can obviously see part A's answer there, but I'll guide you through so you can kind of understand how this equation works. So first, when we look at Kepler's original law, we see p squared equals a cubed. Kepler made these, discoveries a long time ago, and p in this case always represents the orbital, the period, and so normally displayed in years, and then a represents the orbit size, or the time it takes for the object to orbit. Now, Kepler's third law really only helps us when we're talking about two different objects, one object being really massive and the other object being pretty small. So an example of that would be planets orbiting around the sun. However, it does not help us at all when we talk about the different moons and things like that. So that's where Newton's application or Newton's version of Kepler's third law comes into play. You'll see here on the screen that this is the big fancy equation. P is going to be the period. You can see 4 pi squared, so we have constants there with pi. G is a constant as well, if you guys remember from the reading. G is a gravitational constant, so it's always going to be 6.73 times 10 to the negative 11th newtons. M is going to be our mass, and then A is going to be the orbit size. So we can simplify, and I'll scroll down by taking the square roots of everything. Once we plug everything in and do all the calculations, we will actually end up with 3.25 times 10 to the negative 8th. And that's going to be our big number here that we care about. So the first question, if I flip back to it, says, using Newton's version of Kepler's third law, find orbital period of Prometheus. Well, we know Prometheus and Pandora are both the two moons that orbit Saturn. And so these two moons orbit Saturn at these numbers, 139,350 and 141,700 kilometers respectively. So Prometheus is the first one. We're talking about 139,350 kilometers is what the orbit is for Prometheus. So if we flip back over, we talk about converting, and we need to convert because the original problem on mastering astronomy gave us kilometers, but when we look back at our equation, we are dealing with meters. And so a simple conversion of 139,350,000 kilometers. Remember, there's 1,000 meters in every kilometer, so we convert that out and we get 1.39 times 10 to the 8th meters. This is for Prometheus. Top one here is for Prometheus. And when we go ahead and do it at the same time, for Pandora, we convert that out and we get 1.417 times 10 to the 8th meters. So now we can find their orbital periods pretty simply. So we take that original equation, P equals 3.225 times 10 to the negative 8th, and we multiply it by the orbital period that we just discovered of 1.39 times 10 to the 8th. We do that math and we end up with 5.305 times 10 to the 4th seconds. Of course, that's not going to help us very much. So we can convert that into hours pretty easily by saying that there's 1 minute for every 60 seconds, 1 hour for every 60 minutes. And once we do the math straight through, we will find out that the original question of find the orbital period of Prometheus, how long does it take? It's 14.7 hours. The next question asks you about Pandora, so you can use the exact same math for Pandora and you'll come up with 15.1 hours. So you now have parts A and B of that question, 8.45, solved for you. And now all it really comes down to is just manipulating variables using algebra. So you should be able to manipulate variables and solve now that you have the beginning formations. But the main problem that we use is right here, and this is what helps us out a lot. Hope this helps. Once again, this is a difficulty level 5 on mastering astronomy. I would never ask you something like this in an intro level astronomy course. So I hope this helps you out a little bit.